Hello everyone, good morning, good afternoon, good evening to you all. Welcome to this exciting YouTube demo on multi-agent AI systems brought to you by Bridge to Success. Today, we will explore two powerful applications, the Health Wellness Agent for personalized health advice and the Order Support Agent for e-commerce support. These systems leverages multiple intelligent agents working collaboratively. A cutting-edge AI approach, whether you are a beginner eager to learn AI, an experienced developer, a business leader, a student, or a trainer. This video will guide you step by step through the concepts, code, execution, and output, showcasing its relevance to today's trend. Well, as said this, grab a notebook and let's embark on this journey to master multi-agent systems. Before we start, I would like to answer a few questions so that we to gain the context and to understand the criticality and importance of multi-agent. What is the name and the focus of this demo? This demo is titled Multi-Agent AI Systems Demo and focuses on showcasing the Health Wellness Agent and Order Support Agent application. What is this demo important? This demo highlights the power of multi-agent AI systems, a cutting-edge approach that solves real-world problems in health and e-commerce with scalability and efficiency. What is the purpose of this demo? The purpose is to demonstrate how multiple intelligent agents collaborate to provide personalized health advice and efficient order support, bridging theory and practical application. Who is this demo designed for? It is designed for beginners, experienced developers, students, business professionals, and trainers interested in AI innovation and its industry applications. Prerequisites: what tools and softwares are required? You need Docker, Python 3.10 or higher, Git and a code editor like PyCharm or VS Code. What API access is necessary? Valid API keys for OpenAI, which you get it from platform.openai.com, and Pinecone, which you get it from pinecone.io, are required as we store in .env file. What basic knowledge is recommended? Basic familiarity with Python and its command line usage and interest in AI concepts are helpful but not mandatory. What setup steps should be completed beforehand? Clone the repository, github.com, /multi_agents, install dependencies via pip, and configure the environment as outlined in the README. What will you gain by the end? Learning outcomes. That is, what key concepts will you understand? You will grasp Pinecone, vector databases, vector embeddings, Asyncio for async programming, and the agentic multi-agent design. What practical skills you will acquire? You will learn to set up a project, ingest data in Pinecone, and execute multi-agent systems using Python and Docker. And you know what real-world applications you will explore. You will see how these agents apply to health advice, example fitness tips, and e-commerce support, example order tracking, and the very important, what benefits will you take away? You will gain insights into building scalable AI solutions, enhancing career skills, and understanding market trend in health tech and e-commerce. Why this demo matters? Demo value and engagement. How does this demo aligns with current trends? It taps into the growing wearable tech and wellness market, $4.5 trillion by 2025, and the expanding e-commerce sector, $6 trillion by 2025. And you know what? Who benefits from this knowledge? Developers master AI tools, businesses improve services, students gain hands-on experience, and trainers can teach advanced concepts. What opportunities does this open? It paves the way of innovation in healthcare AI, customer service automations, and future multi-agent enhancement like voice input. Well, how can you engage further? Experiment with the code on GitHub, github.com, and work skills /multi_agent. Clone this code, do your experiment, share your feedback, and join our community for more learning. Before we dive into the code, let's cover some key concepts. First, Pinecone, a powerful vector database we use to store and search health and order data efficiently. Why vectors? Vectors are numerical representation of text, allowing us to find similar content fast, which is perfect for our agents to retrieve relevant answers. Unlike traditional databases that struggle with semantic similarity, Next, Asyncio and Async enable our Python code to handle multiple tasks simultaneously, like processing queries and fetching data without waiting. Without them, the system would be slow and unresponsive, especially with API calls. We'll see this in action with the health, wellness, and order support agents. Let's get started. So let's start. Let me open our GitHub repository in workskills. This is Enroll Skills is a GitHub account. In the earlier video, the demo given on the chart-based and agentic AI approach. These are the two repositories, and now we are talking about the multi-agents. And before show the code and execute the code, let us understand the architecture. Let me open draw.io. We can create a flowchart here to understand better on the architecture on a high level. So let me take rounded rectangle. User query will start from here. And we have an agent which is called as triage agent. This will classify. So what the user query, that query will be classified. That classification will be handled by triage agent. We'll talk about this agent more in few moments. And once it is classified, there is another agent that is retrieval agent. Retrieval agent fetches relevant data from Pinecone vector store using embedding. Retrieval agent. This will connect to the database. I want the brown arrow. Yeah. And this is called as vector store. And we are using Pinecone here. Vector store. Once it gets the data, it frames the response. Then we have another agent called response agent, and this will generate human-like response. It generates human-like response with the LLM, and this will take here somewhere. And now we'll connect this arrow to user response. Once it frames the response, it sends it to the user. That's it. And this we call as generated text. Okay. So this is the very high level architecture design about the flow which we are talking about. So there are three agents. There is a user query. User will ask a question, and there are three agents. Triage agents classifies the question and then send it to the retrieval agent. Retrieval agent collect that classification information, send to the vector database, get neighborhood related data, relevant data, and it gets the response, gets the output from the vector database, and it frames that as a human readable by response agent and send that output to query, user query. That is how the flow is. Okay, so let's go to our repository, multi-agent. So this is the readme file, complete information, multi-agent system demo, order support agent, and health wellness agent. The overview, talking about order support agent, health wellness agent, and the architecture. and what all the agents are getting used: try agent, retrieval agent, response agent, vector store. And to get started, prerequisites and installations: GitHub command and environment. So as a developer, it's a good practice that we should have a separate Python virtual environment for our applications. Generally, as a standard, any application, it's good practice is to have that application environment should be, so that you will not have any version dependencies, libraries, conflict, and so on. And the application can be set as a package. So the good practice is it should be built in its own respective virtual environment. And this is the command for creating the virtual environment. And this is the command to activate the virtual environment and running our application. So installation requirement.txt should be installed in that virtual environment. Yeah, this is the key thing. To run our application, we should be having OpenAI API key and Pinecone API key. Just as I mentioned, from where we can get it is like you can get it from the platform OpenAI website and then Pinecone.io, and this is the command for running the application. And this is the application. Not only you probably can run it from the PyCharm, but also from the command line, but also from the Docker. So we have the Docker script also, as if we run this command, it will be get created an image and you can run that. And there are further commands you can go through. And this is the structure. We have multi-agent, order support agent. Underneath of order support agent, we have ingest order data.py, order support agent.py, order data.csv, env file, docker file, requirement.txt, and the same follows for the health wellness agent too. So these are the two examples we will be going to see and understand in the multi-agent. And these are the libraries in the requirements.txt which has to be installed in that specific Python virtual environment. As in the readme, I already mentioned the command. Let's copy this. Now what I will do is I will open the git bash. So firstly I will go to my workspace. So this is my Python workspace. Right click, git bash, open git bash here, paste. So command is pasted, and when we press enter, multi underscore agent.git, a folder will get created. cd agent, yeah, so folder will be get created, and the folder will be looks like this. LL to list all the files, and git status to see all the files, any changes been done, so that those files will get listed. .env file I may not be committing because these files contains my OpenAI key and then Pinecone key. Will type git-pull just in case to make sure all the files local has all the latest files from the GitHub cloud. Yeah, already up to date. This is a good sign. Open PyCharm and create new projects and provide the location of the application where you downloaded. This is the same. Assuming the path is like this, then you say okay, so path is like this, and then now select virtual environment. Oops, yeah, virtual environment, and Python, which version you want to check, 3.10 or 3.11, which is already installed in my laptop. So I'm selecting 3.10 and then create. So what will happen is in the multi-agent there will be VENV, V in the sense virtual, ENV in the sense environment, virtual environment. A folder will be get created and complete Python required libraries will be installed in this one, and then the requirement.txt the libraries what we mentioned, all those we have to install in this virtual environment. So when we create, it will create a virtual environment, and the virtual environment, once it create, all the files will be listed like this, and you can see terminal. Click on the terminal, you can see like this venv environment. As this PyCharm, once we created it, this virtual environment is already activated. For activated, deactivated, in the readme file I already mentioned the commands for how to activate the virtual environment. So now as said, this install openr requirements.txt. So this is the command we have to enter. So once we do that, libraries which are in the requirement.txt will be installed in this virtual environment. As it's already been installed, so I'm ignoring this one. For the API keys, we have to go to platform openai.com, log into the site, and then select project. Well, you can create new project. So I have a default project, and this is the project ID. And under the organization, you can see API keys. So this is the API key I'm using. You can create new key. Make sure whenever you create a new key, copy that secret key and save it in a secure place, secure file, because this key you cannot see again. If in case you lost, you can recreate a new key. That is what the option we have. Okay, so this about the platform OpenAI. And now Pinecone. For the Pinecone, we have to go to the Pinecone website. So this Pinecone, and then you have to log into the Pinecone login. So it asks your Gmail account, log into the Gmail account, and this is the interface you will be getting it. You can create your new index. For our application will take care of creating a new index, adding the data in that index, and doing the search based on that index. So you need not to create an index. But if in case you want any other specific application and you have to test in that application, either way you can create a new index, or else you can create index through Python itself. And now actually we're talking about the API keys. So this is the API key. You have to create a new key. Make sure this is multi-agent. So this is the key I'm using it. And once you create a new key, as the same, copy that, store it in a secure file, and then make sure it is available for you. If in case you lost, missed, somehow got deleted or lost somewhere, then the best option is to create a new key and then use that, because the existing one you cannot view again. As you lost, then it's better you can delete it, because it is no used at all, right? You cannot use it because you lost it. So instead of it remains as is like this, it's better to delete it. Okay, so as you got the OpenAI key and then Pinecone key, then these keys you have to add in the environment file, I mean to say. So this is multi-agent, our repository. In this repository, so these are the two applications, health wellness agent and order support agent. So open the health wellness agent. This is my environment file. Your environment, you can, so this is the OpenAI API key equal to what the key you got it from the platform openai.com. Place that key here, and from the Pinecone, what the key you got it, place that key here, save it. Make sure the name is like this .env. So as we start with health wellness agent, these are all the files what we have which supports executing health wellness agent. Well, coming to .env file, as I mentioned earlier, this is the configuration file stores sensitive key, API key for OpenAPI and Pinecone, ensuring secure access to external service. It must be created and populated before running the script as referenced by load_.env of. And about the Docker, this file defines the Docker container setup, installing dependencies and copying script for a consistent environment. It enables portable execution with commands like docker run as outlined in the readme file, as you can see. And these are like the pre-questions which we can ask while we execute the script. And this is the health data CSV file. This CSV file contains health related data including categories like fitness and nutrition, serving as input for ingestion. It processed by ingest_health_data.py to populate the Pinecone vector store with actionable tips. And health wellness agent. Health wellness agent is this the file defines 3 agents. Here is what like we are talking about multi-agent, and this file is really drives that those 3 agents. One is the triage, retrieval, and response to process health queries and generate personalized advice. It leverages LangChain, OpenAI, Pinecone to classify, retrieve, and respond with Asyncio, ensuring smooth concurrent operation. And about ingest health data, this script loads health tips from health_data.csv, cleans the data, and embed it into Pinecone in the index of health-data using OpenAI embedding. And it uses Asyncio for efficient ingestion, handles errors gracefully, and requires a .env file with API key for execution. And this is the requirements.txt. This file lists Python dependencies like LangChain, Pinecone with specific versions for the project. It used during setup with pip install -r requirement.txt to ensure compatibility. Let's start looking into ingest_health_data.py and we'll execute this one. This script imports pandas for data handling, OpenAI embedding for vector creation, Pinecone vector store to create and connect to our health-data index. While creating index, it sets the vector embedding dimension with 1536 dimension and set the metric as cousin, so that while storing the data in this index, it uses cousin matrix and index organized vectors with the dimension matches embedding. It also uses Asyncio for efficient ingestion, and we use load_.env to secure API keys from .env file. Okay, as said these things, this code is written with all need and necessities, and it loads health_data.csv file. Let's execute and see what will happen. Right click, run. Excellent. This script executed smoothly without any errors, without any issues. See the category and the content, all. It opened the data and digest the data, consume it, embed the data stored in the Pinecone vector index successfully, ingest 11 health documents. Health wellness agent.py. So the health wellness agent.py script implements multi-agent systems to provide personalized health advice. It features 3 specialized agents that collaborate to process user queries efficiently: triage agent, retrieval agent, response agent. Triage agent determines the category of the user query, example fitness, nutrition, sleep, or general. Retrieval agent fetches relevant health data from a Pinecone vector store based on the query and category. Response agent generates a human-like response using the retrieved data and the original query. Well, I said this teamwork mimics human collaboration, making the system scalable and adaptable for human-related applications. Roles of these 3 agents. Triage agent, when we talk about the roles, it classifies the user's queries into 1 or 4 categories: fitness, nutrition, sleep, and general, as you can see here. And it uses chart OpenAI model GPT-4 mini with a prompt to analyze the query. Just an example like, what should I eat for a balanced diet? And it identifies based on this sentence, it's talking about nutrition. So this question will be elected under the category of nutrition, and the implementation utilizes a chart prompt template and str output parser to process the query asynchronously. Retrieval agent roles as retrieves of 5 equivalent documents from the Pinecone vector store, filtering by the category identified by triage agent. If no category is specified and results are found, it fails to back to a general search. Example, what should I eat for a balanced diet? It pulls document like a balanced diet includes 5 serving of fruits and vegetable daily, and the implementation will be like leverage similarity search. So it leverages the similarity search with the embedding from OpenAI, ensuring contextual relevant data. Yeah. And about the response agent, the roles is like generates a new natural language response based on the query and the context provided by retrieval agent. It handles cases where no specific data is available. For example, what should I eat for a balanced diet? It might respond 4 balanced diet including 5 serving of fruit and vegetables daily. And the implementation says it uses chart prompt template with the LLM to craft response asynchronously. And the high-level benefits of these agents: specialization, scalability, robustness, adaptability, user experience. Well, I said in the specialization, each agent focuses on a specific task, classification, retrieval, response, improving accuracy and efficiency compared to a single AI handling all steps. Scalability, the modular design allows adding more agents or category, example mental health, without overhauling the system. Robustness, the fallback mechanism is retrieval agent ensures response even with incomplete data, enhancing reliability. Adaptability, to use the LLM and vector stores, enabling the systems to learn and improve with new data, making it future proof for health trends. And user experience, quick context awareness, response build trust, explaining in health application where accuracy is really matters. So let me execute the script and you can see what it happens. So the question is asked, what should I eat for a balanced diet? Right click, run, and we'll see the output. So all the three agents collaboratively work one after the another and then give the output. See, this is how the output we got it. Context, page, question we asked, what should I eat for a balanced diet? And the answer is, a balanced diet includes 5 servings of fruits and vegetables daily. So these are the documents. Reason, and I got the reason also. For a balanced diet, aim to include a variety of foods that provide essential nutrients. Start by incorporating at least 5 servings of fruits and vegetables each day. These are rich in vitamins, minerals, and fiber, and so on. You can see the answer is very appropriate and relevant with the question what we asked. Let me comment this and uncomment the next question and see what it behaves, what it gives the answer. The question says as, how much exercise should I do weekly? See, all the three agents are working, communicating with the Pinecone, and then finally we got it retrieves the data and we got the answer. How much exercise should I do weekly? For better fitness, aim for 150 minutes of moderate exercise weekly, like brisk walking. To achieve better fitness, aim for at least 150 minutes of moderate exercise each week, such as brisk walking. Incorporate strength training 2 to 3 minutes a week to help build muscles, and so on. See how beautifully the answer is coming up. The answer accuracy you can see with the question. So these three agents collaboratively when work, we can see the fastness, we can see the accuracy, we can see the promptness, we can see the perfection and the collaboration, like getting the information from Pinecone and showcasing and presentation, the using of OpenAI APIs. This is really awesome. With all the mix of collaboration of this whole work of the agentic approach, multi-agentic approach, we can see the better result. And this health wellness agent, as sample, you can see the output. And this you can expand and extend this code base with further large data. As of now, we can see health data. We have few. There are like 11 records are there. Like this, you can add large data, bulk of data. And these agents are smart enough. Pinecone, OpenAI has capability to fetch the information even from the larger set of data and give you the accuracy of information. Now let's check our second example, order support agent. So the structure of the files in order support agent is same as what we observed in the health wellness agent. The description is also the same as what we have in the health wellness agent. Now, if we talk about the ingest order data, imports order data from order_data.csv file into the Pinecone in the index support-data. This is the index support-data. This is the index name. And using OpenAI embedding, and it will create as the same narration of what we did in the health wellness agent. The dimension is 1536 dimensional vector with a cousining matrix for the similarity search. It leverages pandas to read and clean the CSV, validate text and metadata fields, and converts them into document object. Asyncio, we are using here the Asyncio, ensures efficient non-blocking ingestion with a 5 seconds delay to allow. Pinecone index updates and requires .env file with OpenAI and Pinecone API key. The script handles error gracefully, for example missing files or parsing issues, making it robust for demo purpose, and recreates the index If indexes already exist, it will delete and it will recreate it. All this for the demo purpose. Execution will delay. So once we execute, we see the display, the raw data frame, and the process documents, and the confirmation of ingest order documents, showcasing the data preparation process for the order support agent. Okay, so as said this, let's execute the script and we'll see the output, how it comes up. Okay, so this is the output. This is the raw data frame of order_data.csv file, and any invalid rows it will skip, but as of now all are valid, so no issues for us. And confirming the number it's got ingested. So you can see the ingest 11 order documents successfully. This prepares the data for our agent, order support agent, to use. Order support agent.py, where we showcase a multi-agent system tailored for e-commerce order support with agents working together like a customer service team. This script features try agent to classify queries as order or written, retrieval agent to fetch relevant data from the support-data, the index Pinecone vector store which connects to the index loaded on vector store object, and the similarity search which uses the filtered information to fetch the relevant data from the vector store. Retrieval agent, response agent to craft replies demonstrating specialization. Asyncio, using Asyncio, these agents process tasks concurrently, ensuring fast response. Okay, so let's run the script. If you see, this is the query we are asking, where is my order 1234? Executed, we'll see their collaboration in action. The multi-agent approach enhances scalability, adaptability, solving real e-commerce challenges like tracking order, a critical need as online shopping grows to a $6 trillion market by 2025. Okay, so we got the response. You can see the category, the query where my order 1234, and the category is classified as an order, and this is the document got tracked, and this is the answer got framed. See the response. Your order 1234 is currently being tracked under the code XYZ. You can check the status of your order using that tracking number. If you need further assistance, feel free to ask. See how beautifully the answer been addressed for the question been given. You can see the data, order data. This is what the CSV file has the data, and the information is stored in all the transaction been stored here. There are a few records. You can play around with a large number of data also, with the large order transaction data, and using this multi-agentic code base, if you play around with large number of data also, you will see the good result. I mean the appropriate result. As if you see the libraries what we are using is LangChain Pinecone, LangChain OpenAI, LangChain Core, and from this we are using the Pinecone vector store, OpenAI embedding, chart from template, str output parser. These are the very key major modules which actually interacting with these three agents, and these three agents are leveraging the usage of these libraries and producing and providing a better output for the information what we are given to them, for the data what we are given to them. And you know what, like this really works on the larger set also. I suggest and I request you to play around with this. You will get a better result. Well, in the next 5 minutes you will see about the Dockers, how these both the sample application we can execute in Docker and run the command. You will come to know more how these scripts we can execute from the Docker, as once we did that we can use the Docker image in any of other operating system, and then we can use it. Even you can execute it from the cloud also. Okay, so now coming to the final step, would like to show how we can build a Docker container, and we can run the Docker, and then we can run our script, how we can do the ingestion in the Docker, and how we can run the order support agent from the Docker, and how we can see the output. Well, this is currently a command line script. That's how we are executing. The thing is, you can enhance this example with a REST API service, build a REST endpoint, where in the REST endpoint you can ask the question and answer will be given over there, something like that. Or else, even if you want to enhance the command command line, you can pass an input prompt from the command line also as an argument, and that argument you can consume it from the file. The question you can consume it from the file, and that script will answer based on the question as an argument. Like that you can enhance and you can play around. But now it is very important to know, would like to show you how we can execute these scripts from the Docker. So I will, for the benefit of the time, we have the Docker for health wellness agent and order support agent. I will take this order support agent and will show you the example. As this is the PyCharm, right click on the folder, you can see open in, yes, Explorer, go to the Explorer. So we are on that path, double click on that application and we are in our application folder. Now we want the command prompt, command line, so that command line script can be executed. We want the command prompt so that we can run the command lines. Click on this, the address bar, and type cmd, enter. So you will see the command prompt window open on that location, from that path, dir. You can see all the files. We can also see the Docker file. Now we want Docker command so that we can build Docker image for order support agent application. And for this also, the command we have, it is available in the readme file. So let's go to our GitHub readme file of the multi-agent. This is the location, multi-agent, and this is the readme documentation. Search for Docker setup. Okay, we have, you can see health wellness agent, and then okay, so there itself we also can see order support agent. So this is the command we want so that we can build the Docker image for order support agent. So let's copy this command. So this name, it's up to us what the relevant name you want. You can specify for your application and then you can build the image with that name. For now I'm using order support agent, order-support-agent. Copy, we'll paste it at the command prompt, paste, executed. So we have to make sure before we execute, Docker desktop is running in our laptop, in our machine, so that the Docker command will be executed. Otherwise it will be get failed. Just to make sure, I will show you what I'm talking about as it is happening. Docker desktop, this should be running. Okay, so the image is built, Docker images, you can see Docker support agent. This is our image ID, 37 seconds ago, and this is the size. Perfect. Now let's run this image. This is the command we require to run the image. As this is my application path, you can change to the path where your application is. Okay. Paste, run. Oh, there is an error. You can see it's already in use by container. Oh, actually I tried it before, and for the demo I tried again. So what my mistake is, as I tried but I didn't stop it. I should stop it before I do this. Let me stop. So my image name is, my repository is this, image ID means the image name also will be considered as this, and ID is this, but yeah, I want the name only. Docker top order-support-agent. Okay, it stopped. Let me also remove it. rm Docker images. The image is there. I also need to check with Docker ps-l. Yeah, currently only this is running, but it's not running. That's exited. But yeah, that should be okay. So it is not there. Image is available because see, the image is there. Now I want to run this image, and now this command works. So let me copy this command, copy, and now paste it. Okay, see, the image is running currently, and I got the reference ID also for the same. And if you see Docker ps-l, see, order support agent created 14 seconds ago, status up 13 seconds. So it is up, it's running. So what it says is the image is running, and now I can go to this image and run our ingest script so that the data will be loaded in the Pinecone, and then we'll run order support agent script to execute our question so that the answer be given for that. And for that, what is the command to go inside the container is, it is still in the readme.py. I can see this is the one, order support agent, right? So if you say, remember, this is the name I'm using, so that's why I have to use this. If in case you change and you are with a specific named image, you should be using that name instead of this name. Well, for this demo, for this example, as I'm going with this, I will use the same. Now paste, and when I hit enter, so see I am in the Docker. There is a separate Docker container, the container of order support agent. It is a Linux based container, so any of the Linux commands we can execute from here, even though it is my laptop is Windows based. But the beauty of the container system is I can run Linux commands. Like for example, what are the files inside this? What is the command? ls-l. So this gives the list of the files. pwd. This is my app path, root path. You see, we have all the files listed in the container. Linux structure, Linux dependent libraries, and its files. Okay. Anyhow, this is not our subject. /cd app ls-l. We are in our application, and now I want to run ingest order data so that the data from this script, from this CSV file, will be loaded in the Pinecone. You might be talking about the environment, right? How it is reading the environment. I don't see the environment. So while I run the Docker, I already set the environment. See, environment. So I have told in the run itself, hey, you should be using from this path. Okay, order support agent. Right. You should be using the environment file from this path, and this is the file, and this in /app.env. The fact is, I can still see yeah. .env. So the hidden files are also listed. So in environment file is there. Okay, anyhow, let me execute. I want to show you something. Python, even the Python, the version is 3.10. Just want to show and make sure what is the version we are in, because this is the version what we mentioned in the Docker file. Exit. Yeah. So now Python ingest order underscore data dot py should read, this script should read data from order underscore data dot csv, parse it and load it in Pinecone, embed that data and load in the Pinecone index file. Yeah, it's loaded. See the output, and you can see the ingested 11 order documents. Perfect. This is working. So our Docker could able to execute our ingest script and loaded the information in the Pinecone. And now we have the main guy, order support agent. Let's trigger our hero and see what is happening. I want to show you what is a question been asked already. Cat order support underscore agent dot py. This is the question. Where is my order 1, 2, 3, 4? If you want further more questions also, we have the list of questions. Okay, I have not loaded here, but as I showed you already, we have the questions. These are the order support questions. You can ask any of the questions or any other specific questions you think. Also, you can ask. Anyhow, let me start and let me execute Python order underscore support underscore agent.py. It should execute and give us the output, the answer for the given question. Yep, here we go. We got it. All as what we observed in the PyCharm. In the container also we can see. So this is really awesome. Agentic, multi-agentic approach is becoming crazy. Gives us the output in an efficient manner. Okay, as said, we are closer to finish it off our demo, and our request is please go to the GitHub invoke skills multi-agent. Try to clone this repository and use this code base. Enhance, play around this code base. You want to do any contribution, please, it's pleasure. And you can do a lot of things using this code base. You can build your own REST application, REST API calls, enhancing this code base with larger data, bunch of questions. Answers will be given in a relevant way. You can use, currently we use Pinecone embedding. So we have different embedding systems. Even you can use Postgres, you can use Elasticsearch also. Okay, thank you so much for being with this, the whole demo cycle and going through with the multi-agent. We would like to please play around with this, do some experiment on this code base and provide your comments, provide your suggestions so that it will be really helpful for our next demo to come in more better and efficient way and give come up with a nice topic for the next demo. Thank you so much. Have a great day. God bless you all.